Hello students, let us discuss some text problem, that is question number 1 and 2 in a text exercise. Chapter Atoms and Molecules. Question number 1. A 0.24 gram sample of compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by weight. This is a question which is given here. Question number 1. Here a sample of compound, the mass of the sample is given, that is 0.24 gram is the sample of the compound, and the compound is made up of oxygen and boron, and the mass of oxygen and boron is given to us. We have to find out the percentage of it. So how we find out percentage? That is, first of all, write out the given terms, that is the mass of the sample 0.24 gram, mass of boron, that is 0.096 gram, mass of oxygen 0.144 gram. How to find out percentage? The formula for percentage of boron is equal to, that is, mass of boron divided by the mass of compound, and because we are finding out the percentage, so we need to multiply by 100. So this is the formula which we have to use here. What is the mass of the boron which is given to us? The mass of boron was given to here, that is 0.096 gram of boron. So that means we have to, mass of boron is given 0.096 gram divided by the mass of compound that is given, that is 0.24 gram, and because we are finding out the percentage, we have to multiply with 100. So when we do this, that is the 0.096 gram divided by 0.24 gram into 100 give rise to, the answer is 40%. So we get the answer here 40%. As the total percentage is 100, so the compound is of 100%. From this 40% is boron. So then what will be the percentage of oxygen? The percentage of oxygen will be 100 minus 40. So that is equal to 60%. So because the compound is made up of only boron and oxygen, so we can say that in terms of percentage, the overall percentage will be 100. If any of the one of the component percentage is known to you, you can find out the other by subtracting with 100. So that it gives rise to 60%. So the answer is 60%. So this is the answer, that is the percentage of boron is 40% and the percentage of oxygen is 60%. Question number 2. When 3 gram of carbon is burnt in 8 gram of oxygen, 11 gram of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 gram of carbon is burnt in 50 gram of oxygen? Which law of chemical combination will govern your answer? This is the question number 2. So what is given here? Here the reaction between the carbon and oxygen which give rise to carbon dioxide. So we need to write an equation, that is C carbon plus O2, that is oxygen, give rise to CO2, that is a carbon dioxide. So carbon plus oxygen give rise to carbon dioxide. We will be writing the equation here. Now a equation we can define in terms of mole. So 1, here it is 1, that means 1 carbon, here it is 1 oxygen molecule, here it is 1 carbon dioxide molecule, because when I am writing 2C means 2 carbon, that is 2 carbon if I'm writing 2O2 means 2 oxygen molecule. Here no number is there. That means we can write there are single carbon, single oxygen, single carbon dioxide. So we can define this equation in terms of mole, like 1 mole of carbon react with 1 mole of oxygen molecule give rise to 1 mole of carbon dioxide. We can define this equation in terms of mole. So what we can define? That is 1 mole of carbon react with 1 mole of oxygen molecule give rise to 1 mole of carbon dioxide. So what is the mass for 1 mole of carbon? That is 12 gram. Mass of 1 mole of oxygen, that is 32 gram. That is the molar mass. And 1 mole of carbon dioxide mass is 44 gram. We have already discussed how to find out molar mass. So when you find out this one, what is the ratio of 12 is to 32 is to 44? The simplest ratio, when you divide it with 4, will be getting 3. When you divide it with 4, you will be getting 8 here. And when you divide it by 4, we will be getting 11. That means when we divide by 4, all these numbers will be getting the simplest ratio, that is 3 is to 8 is to 11. That is nothing but given in the question. 3 gram of carbon react with 8 gram of oxygen give rise to 11 gram of carbon dioxide. So that means we can say that 3 gram of oxygen is reacting with 3 gram of carbon is reacting with 8 gram of oxygen giving rise to 11 gram of carbon dioxide. So the question it is asked, if 3 gram of carbon is burnt in 50 gram of oxygen, so what will be the product? This is the question which is asked here. As when 11 gram react with when 3 gram is reacting with 8 gram give rise to 11 gram. So can 3 gram react with 50 grams? No, because 3 gram of carbon can react with only 8 gram of oxygen. But here the 50 gram is given, so that means it does not react with 50 gram. Only the 3 gram can react with the 8 gram. So from 50, how much is remaining now? That is 50 minus 8, 42 is remaining. So we can say that even though there is 50 gram of oxygen, but still only we can say that the 3 gram of carbon can react 8 gram of oxygen. I am writing down to this one. 3 gram of carbon is only react with 8 gram of oxygen to give rise to 11 gram of carbon dioxide. So that means if the 50 is given, so from 50 only the 8 will take part in the reaction. Oxygen molecule. So how much is remaining? That is 42 gram of oxygen is remaining. That means from 50 gram only 8 gram will react. So 42 gram of oxygen will be left out. That will be remain as it is without reacting. So what is the answer? That is 11 gram of carbon dioxide is produced. So that is the answer. Here one more question is asked. Which law of chemical combination will govern this answer? Since here only the definite amount of oxygen is combining with a definite amount of carbon, so we can say that here which law is actually govern this concept here? That is the law of definite proportion, because only the combining elements here in the compounds are present in a definite proportion by mass. That is fixed here. Here the combining is taking place by definite proportion. Therefore, we can call it as this law here is the law of definite proportion. So that is about this. to question and answer which we have discussed here. Have a nice day.